So we're supposed to here solve this 3 by 3 linear system, 3 equations with 3 unknowns using Cramer's rule. That requires us to find 4 determinants. The first determinant consists of the coefficients from the left side of the equation. So there's an x column, 1, 2, 2, a y column, -5, -1, -3, and a z column, -2, +2, and -1. So we have to compute this 3 by 3 determinant first. And then we'll have to find a similar one for dx, and for dy, and for dz, which will just replace the x, y, or z column by the 1, 0, 0 on the other side of the equal signs. Okay, to solve this 3 by 3 determinant, the easiest way is to copy the first 2 columns to the right of this matrix. So 1, 2, 2, -5, -1, -3. And next we begin this process of multiplying down the diagonals. So the first term is going to be -1 times -1 times -1. So I'll write this, I'll write this underneath here. So 1 times -1 times -1 is +1. And now we're going to add to that the next term. We go over another diagonal, so we're going over to this diagonal now. We have -5 times 2 times 2. That's -20. So we're adding a -20. Or just think of that as, yeah, let's add a -20 like this. And then we have the third one over. So it's -2 times 2 times -3. That's -4 times -3 is +12. So we're halfway done with this one. Now we have to subtract what we get going using the other diagonals. So we have 2 times -1 times -2. So that's 4. And then the next diagonal over, we have -3 times 2 times 1. That's -6, so we're adding here a -6. And then finally we have -1 times 2 times -5, which is +10. So what we end up with for D is 1 plus 12 is 13. 13 minus 20 is -7. And in the parentheses here we've got 10 minus 6 is 4, plus 4 is 8, so we're subtracting 8. So D ends up equaling -15 for this linear system. And we have some more determinants we need to find. So let's start with d sub x here. With d sub x, it's the same as the original matrix that we started with, except the x column gets covered with 1, 0, 0. Now, the other 2 columns, the y column is the same as what it was, -5, -1, and -3. And the z column is the same as what it was, -2, 2, and -1. So now we need to copy the first 2 columns over. Let me make a little more room for myself and just remind us over here that this is D. Okay, so we have to copy the first 2 columns over to the right of this matrix. So 1, 0, 0, -5, -1, -3. And now we can start the process of calculating this. So to begin with, there's this diagonal. Multiply those numbers together and you get 1. 1 times -1 times -1 is 1. And then we add the next term, which is -5 times 2 times 0. Times 0 means the whole thing is just 0. And then finally, the third diagonal over, -2 times 0 times -3. You like to see zeros in these things because that's just 0. Then we subtract going the diagonals that are going the other way. There's a 0. That's what we like to see. 0 times negative 1 times negative 2 is 0. The next diagonal over is negative 3 times 2 times 1. That's negative 6. So we're adding a negative 6 here. And then finally, another 0. Great. Because that means negative 1 times 0 times negative 5 is 0. So zeros make these easy to compute. So this ends up equaling 1 minus a negative 6. Minus a minus 6 is plus 6. So d sub x is equal to 7. Now that we know that d sub x is equal to 7 and d is equal to negative 15, we know that x, we've solved for x already, we know that x is equal to d sub x divided by d. So in this case that's 7 divided by negative 15, or negative 7/15. So we found our solution for x, but we still need to find y and z. So let's go after y next. To solve for y, we'll take the original D matrix and use 1, 0, 0 to cover up not the x column but the y column. So to do this I have to clear some space here. But let me remind us of what the solution is. The solution we'll put right up here. The solution is the point, the x-coordinate of the point is negative 7/15. We have yet to find the y and z columns.